So, dear students, we were solving the problem. This spherical shell, which is fixed on ground, is given to us. Inside this shell, there is a point P, and from this point, a small ball is released. Point P is at a height h, and this distance is delta, which is tending to 0. All collisions are elastic, so we need to find out what is h, what is the value for h, for which second collision happens. The second collision happens at point O. That means this ball goes like this and it comes here. And for this case, we need to analyze whatever h we get on calculation. For that value, we need to analyze whether the motion of the ball will be harmonic or not. We very well know harmonic motion means periodic motion. Be careful, harmonic does not mean simple harmonic. Harmonic means what? Periodic motion. And if it is periodic motion, harmonic motion, then of what period? So, dear students, if IIT professors ask this, then they want us to do this. Here we go. We should be able to draw this figure either mentally or on a piece of paper, and we should be able to write this and this, these equations, and this is the final result. You must have got such result. IIT professors can ask this situation even in integer type section. In integer type section they can ask by saying h equal to r by n, find integer n. So we can say n equal to 8. We can bubble in OMR sheet 8. Dear students, focus. First of all, this is the situation. Focus. When this ball is released, it strikes here. The collision is elastic, so it will go like this. We want this ball to reach here at point O. Now the geometry involved is, see, from center to this point, if we draw a line which is radius, and if this angle is theta, then see, this line is parallel to this line, so this angle is equal to this angle. These two angles are same. Moreover, this collision is elastic. Elastic collision is what? Just like reflection of light. So, angle of incidence is equal to angle of reflection. So, this angle theta is equal to this angle theta, right? Due to elastic collision. One more thing, because this point is very close to this vertical diameter. And that is why it is written here, what? This figure is not to scale. We are zooming this figure a lot in order to clearly see all the angles. Actually, this point P is very, very close to this vertical diameter delta tending to 0, right? So, range of this projectile is what this? And can we write this range as r theta? R is radius, theta is the angle in radian. So, r theta is the range of this projectile. Now, dear students, how do we write range of projectile? U square sin 2 theta by g. We very well know. So, velocity, in other words, the speed of this particle on reaching this point would be what? Under root 2 gh. So, let us write that range. Range of projectile here, r theta, is equal to u square sin 2 theta by g. So, this is pi by 2. Pi by 2 minus 2 theta. On simplifying this, this is sine pi minus 4 theta. Sine pi minus 4 theta is what? Sine 4 theta. Because angle is small, so sine 4 theta is what? 4 theta. So this whole sine value can be replaced by 4 theta. Multiplied by this, on cancelling all these terms, we are getting h equal to r by 8. So r by 8 is the final result. Right? So you are getting how to do this. All this concept is now very, very clear to you, right? Let's move forward to the next part of the problem. In next part, what is asked? that this part is given to us. For this calculated value, for h equal to r by 8, we need to analyze whether motion of the ball will be harmonic or not. See, dear students, motion will be harmonic. It will be certainly harmonic. How? See, in previous analysis, this ball goes like this. Why this figure is not to scale? Because this projectile motion will not be this small. It will not be this small. Actually, this projectile motion will be like this. It will be, dear students, focus. This concept is very important. This projectile motion will be like this. See, because this ball is very close to this vertical diameter. When it is released, this ball will strike here. It goes up. On parabolic path, it goes here. Again, projectile motion, it goes here. Then it reaches here. I've shown it like this. 1, 2, then this downward path 3, then this upward path 4, downward path 5, upward path 6. 6 steps and then 6 steps back. 6, 5, 4, 3, 2, 1. The ball reaches back here. In this way, one cycle is complete. So this is harmonic motion. This particle will keep on repeating this cycle, right? The point is, focus, the person who is watching this experiment from a large distance will get a feeling as if the ball is moving along vertical diameter all the time, up and down. That person would get a feeling as if this ball is moving along this line only, like this, like this, like this, like this. This is the feeling if you are looking at it from large distance. But if you closely observe, then motion of the ball would be something like this. You are observing very closely, so you can see all these parts. And one more important thing, this height of the projectile is equal to h, which is equal to r by 8. Why it is so? Because all these vertical lines are very, very close, right? So the time period will be equal to what? 12 times t1. What is t1? t1 is this time, one time. So for that t1, we can simply write h equal to half g t1 square. So t1 is under root of 2h by g, simple. And 12 times this value is the time period. So 12 times this, placing h equal to r by 8, we have found in previous part r by 8. So placing it here, we are getting this value, 6 times under root r by g. This is the time period. This is the time period. You have got total concept very, very clear. Very, very clear. Right? One simple thing, dear students. If any one student anywhere in India gets advantage in his or her JEE Advanced preparation, then I will consider my efforts successful. So all dear students, you must have got your All India rank with the help of revision problems. Keep working hard to improve your All India rank. The next revision problem will come in next 24 hours. Follow the complete video chain to get a grip over what exactly IIT professors want. Happy learning, dear students.